Hi, welcome to all the participants to this webinar on setting up materials recovery facilities. The webinars are being organized by Terry and ABT Associates under a project funded by UNEP, Climate and Clean Air Coalition's Waste Initiative. We have today with us Mr. Michael Kalish. Mr. Kalish is the Vice President at SCS Engineers, where he is the national expert for transfer stations. Mr. Kalish has been the project manager and lead designer for several new solid waste facilities, major transfer station renovations, and expansions all across the country. He has over 15 years of solid waste experience, both as a consultant and as a municipal employee in California. Mr. Kalish has also worked on a variety of engineering projects involving LFG, landfill gas to energy, landfill closure, and methane mitigation design. Without much further ado, I'll hand it over to Mr. Kalish, and as always, we will have the questions and answer session at the end of the presentation. Before the presentation, we have a video which was shared by Mr. Kalish, so we'll share the video with the audience now.
In spite of our best intentions, the majority of recyclables still end up in landfills. About 1,000 pounds per American per year are left in landfills, never to be recovered. The problem is obvious, but what if I told you the answer may be closer than you think? In the small community of Troy, outside of Charlottesville, Virginia. Here, Vandalinda Recycling is revolutionizing the separation process, harvesting more recyclables than previously thought was possible, substantially reducing the amount of materials that reach the landfill, leaving environmental impact at a minimum. Let me introduce you to the Materials Recovery Facility, one of 2 recycling facilities on Vandalinda's campus. So how does it all work? The average person or business disposes of their garbage as they would usual. Your chosen hauler drops it off at the facility rather than a landfill. Here the initial screening process takes place, looking for things such as mattresses, propane tanks, and acid-based batteries that cannot be processed through the machine. The harvesting process begins at the bag shredder, where bags are broken open to expose the potential recyclables inside. In stark contrast to a landfill, the materials don't just sit there, they move. The contents of the bags are quickly moved to the pre-sort line. While traveling down the pre-sort belt, the contents are combed for non-recyclables that may have been contained in the bags, while some employees are tasked to look for obvious recyclables that are dropped into the bins below. The now combed material moves up a conveyor belt to a secondary pre-sort line. On the second pre-sort line, materials are once again looked over for any non-recyclables as well as anything that might damage the machine, such as garden hoses or electric cords. From here, it enters the trommel. The trommel serves several purposes, including breaking up any large material or bags that have made it this far in the process. And more importantly, this is where smaller fine material and organics are separated from the batch. The smaller materials fall through the small grates in the trommel. The recyclables move onward and upward to the next phase of the process, the cardboard separator. The heavier and larger cardboard is pulled up. The large gaps allow smaller paper, plastic, metal, and glass to fall through to another conveyor belt. The glass, plastic, and metal move on, while the large majority of paper is separated and sent to bale at this fiber screener, which uses an innovative blowing process. The remaining recyclables move up yet another conveyor belt to the sort line. During the first phase of the sort line, plastic bags and paper products are hand separated and placed into vacuum tubes. This complex yet simple vacuum system allows all the materials to end up in their rightful bin. Next comes the ferrous metal magnet. Ferrous metals, or magnetic metals like iron and tin, are separated from the batch in a blink of an eye. The remaining materials move up a small conveyor belt to an optical sorter. This amazing machine within the machine recognizes different types of plastic and separates them at lightning speed. Now all we have left is the aluminum and a little residual. Aluminum is separated by the eddy current machine. This machine makes the aluminum essentially hop over into its proper bin, while the residuals fall onto another conveyor belt to go back through the process once again. So what happens to these materials once separated? When a bin is filled to capacity, such as this plastic bin, the bin is emptied and transported down the line via a large conveyor belt. The contents are moved to the baler, where they are compacted and baled. The entire bin of plastic that would have otherwise ended up in a landfill is now condensed to a relatively small bale. The bales are loaded for transport and sent to the appropriate facility to be repurposed. The facility is equally proficient at separating both mixed waste and source-separated recyclables, and takes in tons of recyclables that may have otherwise ended up in the landfill. All of this to make the world just a little better place for our future.
All right. Well, good afternoon to you folks. I am Michael Kalish, and I'm going to talk with you about setting up of material recovery facilities. Thanks to a little video from a friend and client of mine, Pete Vanderlyn, you got a pretty good overview there of how a process runs through a small materials recovery facility that's here in a somewhat rural community in Virginia. So I'm going to start off today, what is the solid waste management system? Generally speaking, solid waste management system is made up of 5 separate components. Starts off with waste generation, which typically occurs in residences, institutions, markets of some sort, business and commercial establishments. And each of these generation sources have different types of waste. And we'll talk about the importance of understanding that waste generation as we go on through my presentation here today. And the next step in the solid waste management system is storage. Now, granted, this is typically a short-term type of storage in the trash bins in people's homes, and trash bags that they put out at the curb for collection, or dumpsters that are sitting behind businesses or at construction sites and all that. Once that waste is placed into a storage container of some sort, it's got to get collected. Typically, collection we see that happens is with vehicles. People running around operating these vehicles to collect this waste, conglomerate it together into a truck that has a larger capacity than that storage bin does, where it then takes it on to its next step, which is some sort of processing and treatment. And we're going to concentrate on this processing and treatment section of the solid waste management system in my presentation here today. Processing and treatment entails things like materials recovery facilities, or MRFs, or MRFs as they're commonly referred to, and as I'm going to refer to them here during my presentation here today. But processing and treatment also includes composting facilities and other waste treatment facilities that may change the characteristics of that waste stream as it comes in. It may be as simple as changing the size of materials and grinding it so that it can be used for combustion, for example, as a fuel source. And then our final step in our solid waste management system is disposal. Very commonly, very typically, that disposal is a landfill. Here's where I had that video shared. So as you saw through it, it gave a very good overview of a MRF facility and how materials flow through a facility, and how different technologies are being used to automatically separate some of those materials, and labor is used to separate those materials as well. So let's start off. What is a materials recovery facility? By definition, a MRF is a facility where recyclable municipal solid waste is processed and separated using manual or mechanical methods. And as you saw again in that video, it could be a combination of those methods as well. By definition, manual sorting is where components are sorted by hand. So it uses, depending on the number of materials that you're looking to pull out of that material stream, will depend upon the number of employees that you need operating that facility. And mechanical sorting is where components are separated through the use of mechanical equipment. Could be trommels, could be screens, could be different types of technology separators that will pull, and they're geared towards aiming on a very specific material. Here's some nice pictures of manual sorting. As you can see, it is a series of people lined up along, in these cases here, a conveyor belt. But in smaller type facilities, we could have people lined up around a table, and material is dumped onto a table, where then people are picking through the materials sitting on a table or sitting on a floor to pull out certain materials. The key with manual sorting is that you're trying to pull out the materials that are the easiest to get out. So you're looking for things in that material stream that are not as common. So you're pulling out the smallest number of things, and the largest number of things stay moving through the sort. Here's some example of mechanical sorting equipment. In our pictures here in the upper left, we've got an electromagnet, as you saw in the video, helps to pull out ferrous metals. Lower left, we've got a screen, or finger screen, which helps to separate larger materials from smaller materials, so it's a size separation, generally speaking. And off to the right, we have a trommel, which spins, you can see by the wheels there, it spins the material through it. It has a screen set in it, and it will separate materials by their size. It also helps to open things like bags by tearing them and moving materials around to separate them so that they're easier to pick in subsequent steps through the sorting process. So MRFs are generally defined as two separate classifications. First is a clean MRF. And a clean MRF is commonly used in communities where there's already a high degree of segregation that's occurring right at the source where materials are being generated. So that's in people's households, in their places of business, at schools, at markets, grocery stores, those type of places where the waste materials are being generated. We're then doing source separation at that location. In clean MRFs as well, we're typically separately targeting biodegradables versus non-biodegradables, and hopefully those are being separated out in the very beginning of that process. Biodegradables can contaminate the non-biodegradable waste stream, material stream, so we're looking to try and get that segregated out as early as possible in the process, the solid waste management process. Contrary to clean MRFs, we've got dirty MRFs. And in a dirty MRF, nothing is separated at the very beginning of that process. Everything comes together. People throw everything into one bin. All the trash, all recyclables, all go into one bin. It all gets stored in a trash can, is all collected together, and goes to a facility where then the segregation occurs. Dirty MRFs are actually a little bit more common because it takes some of the work for where it's being generated out of the equation, and so it makes it easier to capture all the materials from an area and then manage the recyclables from there. What tends to happen with dirty MRFs, though, is that paper products tend to get more contaminated by liquid components and things in that waste stream, food and the like, and that can cause a problem with the management of some of those type of materials. It's important to note that even with a dirty MRF, composting of the biodegradables is still possible as long as there's a separate facility that can handle those materials. And as I think you would tend to expect, that when you have different materials and different quality of materials and all that kind of stuff mixed in, as you do with the dirty MRF, the processing time is going to increase to be able to pull out the proper materials from that material stream. But it's also important to note that the end products, the materials that you pull out and send to secondary markets, are essentially the same for both. The plastics, the metals, and all that kind of stuff generally are not contaminated to a point where they are unusable, even with a dirty MRF. So when we're looking to develop our MRF, we've got to find a site for it. So I'm going to talk through some of the siting criteria that we look at when considering the right place to locate a MRF. Certainly, we're building a facility of some sort, where the size of it may vary depending on the amount of material that we're going to send through it. But generally speaking, for the convenience and the efficiency of moving materials in and out of a facility, it needs to be close to existing roads. But certain roads are not necessarily compatible with the types of vehicles that will be entering and exiting from our MRF. So we're going to want to do and check on the impacts to existing traffic surrounding the potential location for this facility. Waste trucks bringing materials to this facility are relatively large trucks, 30, 40-foot length in size, 10 meters. And waste vehicles and tractor trailers that are taking baled materials and the residuals away from this facility are double that size. So having those large size vehicles driving around in, for example, residential areas where small kids are playing and there are schools and things is not necessarily compatible. We're also looking to site our facility somewhere near or in the middle of an urban area. Key to here is we want to keep our facility as close as possible to where the waste is being generated. The further we have to move materials, to drive materials around, the less efficient the overall solid waste management system becomes. So if we're going to manage and process our waste, we want to try and do that as close as possible to where that waste is being generated. This allows the smaller vehicles that are bringing materials to that site to have to drive smaller distances. And then subsequently, the larger vehicles that may need to go longer distances to take these materials either to the recycling markets or the residuals for ultimate disposal, those larger vehicles are more efficient at going the longer distances and have a larger payload, a larger amount of materials that they can carry with them. MRF facilities also, we like to try and maintain buffer areas, distances of 100 meters or more, where we do not locate this facility next to what are termed as sensitive receptors. And as I mentioned, as I referenced before, these are areas like schools, places like hospitals, parks, residential areas, areas where people are going to be out and about and could be affected by the noise, the odors, the dust that may come from these type of facilities, and the traffic impacts as a result of these type of facilities. As you saw from the video, MRF facilities tend to be a large warehouse type of a large warehouse type of building, and so as a result, we want sites to generally be flat if we can get that. This will help to reduce our costs of developing that site, so that we don't have to flatten out hillsides and the like, gently sloping so that we can manage water that occurs from rainfall, keeping that separated from our facility, and the liquids that may come from our MRF as well, which is termed as leachate. We need to keep that separated from rainfall and stormwater. The other key in this, and this is sort of a true when it comes to any sort of a large type of facility, but we want to generally avoid flood-prone areas. If our facility gets flooded, it can't operate, and if there's materials around, it could cause contamination as well. So as we're looking to now get into the planning stages beyond just finding a good site, we need to figure out how are we going to design this facility? How are we going to size this facility? And the first step in this overall process is really understanding the nature of the materials that we're going to be dealing with. Where is this material going to be coming from that we plan to be managing and to be separating? As I mentioned, the different types of waste generators, residential, commercial and institutional, schools and offices, industrial facilities, and hotels and restaurants, all have, as you can see here, different types of waste that are generated in each of them. Residential waste, or our typical MSW, includes newspapers, mixed papers, plastics, cans, yard trimmings, food waste, the like, where commercial schools, offices, predominantly is leaning more towards the paper side of things. You're going to see different types of office paper and cardboard, that kind of stuff. Industrial type facilities, you're going to have more packaging materials. So we may see more plastic wrap, plastic materials showing up in our waste stream, cardboard boxes there as well. And hotels and restaurants, well, we're going to have large plastic bottles and tin cans. Food is typically purchased in large bulk type sizes, so we get large amounts of materials that hold that food. And of course, we're also going to have food waste as well. So really understanding that waste stream, that generation of waste, where it's coming from, what types of materials, is really important. And so we certainly recommend performing a waste composition study. And the key to a waste composition study is what's termed here as, we do it as end of pipe waste characterization. We're looking for the amount, the characterization of the waste that gets collected and would be delivered to a materials recovery facility. And we do an evaluation of that waste to find out how much and what types of materials are in that waste stream and are able to be processed, able to be separated from that waste stream and stored and subsequently sent on to recycling markets. What will come out of all that as well is there's going to be a certain amount of materials that you're going to be able to pull out of that waste stream, but there's a certain amount of materials that you're not going to be able to do anything with. Either the markets don't exist to manage it, or it's contaminated, or it's a material that you just can't do anything with. Those are what are termed as the residuals. And you're going to have to manage those materials as well. Those are going to have to go off to a waste incinerator or go off to a landfill ultimately at the end of your process. So you need to understand the full circle of that waste stream and how it gets managed. Typical numbers in your MSW waste stream, around 40 to 50% of the waste that's in that stream is recyclable, but it's not all recoverable and not all saleable. And that's the difference where the end of pipe comes into play. So here's a sample output of a waste composition study. In this instance, organics, paper, and plastics, generally speaking, are the major components of that waste stream. So any sort of a MRF that it gets developed to manage this waste stream is certainly going to want to target at least, the bare minimum, those three components. If there's construction and demolition debris that you're going to decide to target after, well, the technologies may change on the separation and the labor force that you might use to be able to pull those type of materials out. We've got different concerns with construction and demolition debris. In the video that I mentioned, the MRF facility was handling municipal solid waste, and they did reference that they had a second facility on that same property. And that second facility actually is a whole separate construction and demolition debris recovery facility. So once we look at our waste composition, we understand what types of materials and how many materials are in that waste stream. We then go back into looking at the area that's going to be potentially serviced in a location where we place our materials recovery facility. We go back to what is the waste generation? How much waste can be generated to serve as the source of these recyclables? If we're going to expect to get 10 tons per day of materials, then our facility will be sized accordingly. If it's going to be less, it may change the technologies that we use, and if it's more, it may significantly change the technologies that we use. So we need to then step out to where is this waste being generated? How much of it do we expect to be coming into these facilities? This is also important in understanding the amount of materials that will be leaving this facility for secondary markets, so that we can consider what are the economics of our facility, and how much material and what value do we expect to get in the facility as well. Understanding waste generation, we also project into the future. This facility is not just going to be build it in 1 year, operate it for a year, and let it go away. It's going to be build it in a year, operate it for 10, 20, 30 years perhaps. So you want to understand how the growth in the area that is serviced by this materials recovery facility is going to change. Generally speaking, with an increase in economic activity, generation of waste increases as well. It's also important to point out that generation of waste in urban areas tends to be higher than the generation of waste in rural areas. And the generation of waste also happens to be higher in areas of higher income versus areas of lower or medium income. So once we understand our waste generation and the future of waste generation that this community is going to be serviced by this materials recovery facility, then we need to consider what's going to be the collection of waste. What is the percentage of the waste that we expect to be collected? And I think is probably recognized is that the collection of waste tends to be higher in urban areas versus rural areas. We may get 70, 80, 90% of the waste that's generated in an urban area, where we may only get 30, 40% of the waste that's generated in a rural area. As people spread out, it's harder to and less efficient to try and get materials collected. We may now depend on people to bring the materials to us. And there's just a certain number of people that you're not going to be able to service. So you need to understand the community that then is serviced by this MRF. And how many areas are we going to be able to service? Are we going to be able to service all of the areas within our waste shed that we're targeting? So once we understand then how much material we expect to be able to collect, the other key in this is what type of waste diversion may be going on that's going to prevent materials from coming to our facility. And this is where the importance of the end of pipe analysis comes into play when we do our waste composition and all of that, because we are targeting the waste that would be coming to the facility with that end of pipe, as opposed to waste that's getting diverted before it even gets picked up and heads to our facility. And maybe things that happen at a household, for example. People may segregate out food waste right at their home because they compost it out in their backyard. They use it in their gardens or whatever the case may be, or they're feeding animals with that leftover food. Are people segregating out recyclables ahead of time, clean, where you have clean recyclables ahead of time, and maybe they're going to a whole separate facility, or they're going to a junkyard. People are separating out materials and taking them to a junkyard and things like that, and taking care of some of that before it comes to the facility that you're planning to build. So trying to identify what type of waste diversion is occurring before it even hits a truck that heads to your facility is important as well, because you may be able to start to recapture some of that with your facility. And if you target those materials and with advertising and all that, you may be able to pick up those materials and add it to your stream of materials that you're handling. The next thing we're going to talk about is the market requirements. There may not be a market for different types of glass materials in the area where you're looking to develop a facility. And if there's no market to take these materials, if you collect them and store them, there's only so much space you've got for storage. There's only so much time you can store that materials. And if you don't have a market to take that material to, then you can't do anything with it. So you're wasting time and energy in segregating out those materials. The other key component in all of this is when you're looking at developing your materials recovery facility, you need to know how you need to process those materials to satisfy the requirements of the markets that you are going to service. For example, some of these things, cans typically need to be flattened, baled, dry, and clean. So the storage requirements and the management of these type of materials are going to say, we cannot store some of these products outside because they're going to get dirty and they're going to get wet when it rains. Plastics, they typically, again, they need to be baled, and they may want to be separated by the type of plastics that they are. Certain markets will take number 1 plastics. Certain markets will take number 5s, number 7s. So if they're all commingled in the beginning, you may need to do a secondary sort to separate them by the different type of plastics. Or you may need to send it to a different market or get less value out of it because it's not segregated out based on how the market wants it when it gets delivered to them. Paper, again, typically wants to be separated by its grade of material. It needs to be baled. It needs to be clean. And again, it needs to be dry. So it can't, generally speaking, it can't be stored outside. And glass typically just needs to be separated by color and left dry if at all possible, but it tends to dry relatively easily. So marked glass is something that is able to be stored outdoors. And then, of course, the all-important component in developing a MRF is the economics of it all. It's got to make sense. If you're going to spend the money to build a facility, you have to understand that there's going to be a cost associated with buying land, building that facility, operating that facility, but there's value in perhaps getting a tipping fee to have those materials delivered to you, and there's value in selling those recyclables as well. So understanding what the prices of recyclables becomes very important, because with the way that the global economy is, materials are moving all over the globe. So understanding what the global economy is doing, and in correlation to that, the demand from the manufacturing sector specifically is going to guide the price of recyclables. So the market is constantly fluctuating, going up and down. So you may want to design your facility to have extra storage so that in the periods of time when the market for recyclables is low, you can store your materials. And then as the market turns and the value of those recyclables move up, then you can sell your materials to get the most value out of operating your facility. So let's talk about some of the costs. We're going to start off with the development cost of the facility. You got to build a facility. What kind of money do you need to spend to go into it? Well, the first step is doing some of these feasibility studies, the waste composition, the waste generation, understanding, where the materials are coming from, and then looking at what are we going to need to do to process the materials that we're getting? What are we going to need to do to process them so they're suitable for recycling markets? How much is perhaps that going to cost and all that? So a feasibility study looks at the big picture from generation to disposal to end markets, looks at the big picture, does a cost-benefit analysis for this facility to determine, is it feasible? Is it going to make economic sense? Once we understand that, then we'll do engineering design. We got to build a facility. We got to design. We got a building. We got to lay it out on a property. We have to design our roads to accommodate the traffic. Make sure that we've got space available for traffic to back up, because it takes time to get in and get weighed and unload their materials and leave their facility. So we've got to do a design for engineering in conjunction, or typically right after we do a feasibility study. Generally speaking, the costs associated with a feasibility study are 2 to 3% of your overall development costs. And generally speaking, the engineering costs of a facility are in the 5 to 6% of your facility development costs as well. In conjunction with our engineering design, then we've got to go through environmental permitting of some sort. And permitting may vary depending on the size of the facility. Small facilities may have very little to no permitting requirements because of the process that they're doing in the management of recycling materials. Whereas large facilities may have to go through a full process for a solid waste management permit, because yes, you're going to be managing maybe large quantities of recyclables, but you're going to be managing large quantities of residuals or just waste at that point in time as well. So understanding the size of that facility is key, and understanding what perhaps the permitting requirements are going to be. Then we've got to get a site. We've got to buy a site, and maybe you own it already, and that's easy, and that's great, and maybe there's some permitting that you need to do to zone that property for this type of facility, but perhaps you have to buy a site. And so you're going to look at what sites are available, hopefully, and preferably closer, as we talked about, to the center of the waste generation to make it more efficient for the overall solid waste management system. Then we have to develop that site. And site development costs are highly variable depending on the terrain. As I mentioned, we want, generally speaking, flat site to be for this type of facility. So if it is not flat, then we're going to have to spend site development costs to make it flat. The different types of land use that are on that property right now will affect the development of that land. In addition to the land use that surrounds that facility will affect the development of that site. You may be required to provide certain buffer areas around the exterior of the property so that you minimize impacts to adjacent neighbors. Type of vegetation on that site will affect the cost of site development. Site with lots of trees are going to need to be removed, and that will increase the cost of the development. And the accessibility of that site. Are we going to be able to get construction vehicles in and out of that site relatively easily or not? So those are all factors that will affect the cost of site development. We got to build a facility. We've got to put a building up, a large warehouse type of a building to handle the equipment and the people inside that to do the operation of management of all of that material. And are there other ancillary facilities that you're going to look at developing on site? Typically, we're going to need a scale house of some sort to weigh the materials coming in and leaving our facility. Do we need office facilities? Do we need locker rooms, break room for employees, that kind of stuff? What about maintenance shop for equipment and all that as well? So what type of operations are going to go on at this facility so that we can understand the construction costs, the capital construction costs of physically building this facility. We have to buy equipment. MRFs are very equipment heavy, whether it's a fully automated type of a system where there's conveyors and all the different equipment to do the separation. Plus, in addition to, you're going to have loaders and you're going to have forklifts and mobile equipment that's moving materials about your facility as well. That's all equipment that's going to need to be purchased. And before you can get up and running, you've got to hire people and you've got to train the people. And you've got to get people trained up front so that they know how to operate the equipment, how to maintain the equipment that's going to be the lifeblood of this facility. So those are all what's called the capital costs. There are development costs. That's what it takes to get the facility up and running. But we've got to keep that facility up and running. And so we've got ongoing operations and maintenance costs for our MRF as well. And always the number one cost in any type of a facility is employee salaries. We've got to pay people. That's going to be one of the biggest costs. If it's a fully manual facility, maybe we're having lots and lots of people, and so that's going to increase our employee salary costs overall as a result. We're going to have utility bills. Electricity and water are typically needed to operate these facilities, to operate that equipment, for washdown, and for employee facilities. We need electricity and we need water. We're going to need to buy fuel to operate the mobile equipment that's running around our site. And if we're heating, we need to buy fuel to do that heating as well, whether it be natural gas or it be fuel oil or something. That may be a possibility as well. We're going to have to maintain not only our equipment, which is a given, right? We operate equipment, it's got to be maintained, and oil needs to be changed, and tires need to be rotated and purchased and all that, but our facility physically needs to be maintained as well. If a building is not kept clean, then dust will develop, and that can cause a fire hazard. If our site is not maintained litter-free and kept clean. That can attract vectors. It can cause odors. It can cause nuisances with blowing materials, waste materials blowing off property and affecting adjacent neighbors and down the road and all that. So we need to maintain our facility in addition to our equipment. It's important for the health of the employees. It's important for the overall impression that the community has on the facility that we're operating. People think about solid waste, whether it be a landfill, whether it be a transfer station, whether it be a recycling center or a MRF. They all have the impression that it's trash. And by keeping a clean facility, we can help to change that image that people typically get when they think of trash. Because we've got people, we've got supplies that are going to need to be purchased. We're going to need to have health and safety equipment for our employees. We're going to need, toilet paper and paper towels and all the like. And where there's people and things are getting used, we're going to need to buy supplies. If we have offices, we're going to need office supplies to be able to do billings and all that kind of stuff. So those are O&M costs as well. And the key one that sort of may get overlooked in all of our O&M costs is, as I mentioned, there is a significant amount of residue that's left at the end of our process, and that needs to be disposed. And so we're going to have to pay to dispose of all of those materials. That's not a one-time thing. That's an ongoing cost that's going to occur throughout the life of this facility. So we have to include the cost of waste disposal and perhaps even the cost of hauling that ropes into the waste disposal cost, the cost of hauling that material to its ultimate disposal facility. Typically speaking, as sort of a good rule of thumb, O&M costs may vary somewhere around 5 to 10% of our overall facility cost. So we've kind of gone through the planning of our MRF and sort of the big picture things that go into our MRF and what we got to think about. So let's talk about the design of this MRF. What components do we put into our MRF? And I'm going to talk through this as the material flows through our facility. So the first step, we've got to have an area to receive the incoming waste. It's called a tipping area. Open piece of floor where trucks will come in and they will dump the materials on the floor so that it can go through the process from there. And a good rule of thumb is we're hopefully having 2 days worth of floor storage. That can help to accommodate problems in getting materials because of weather-related issues or other type of issues in getting materials coming to our facility. It also gives us a buffer and we can keep materials coming in. Materials can be continually processed going out if we have this buffer in it. We run 1, 2, perhaps 3 cycles of employees throughout the day so the materials keep flowing through our facility. So it's good to have at least 2 days worth of storage available in our receiving area. Right from our receiving area, we go through some sort of an initial sorting and process area. Whether it be something that's done by hand, where certain materials are pulled out, as mentioned, things like batteries or propane tanks, things that we don't want to run through a process line. But this also does include our process line, whatever it may be. It may be as small as a couple of tables and people standing around it, and it may be as big as full conveyor belt systems and all that. So we've got to provide an area depending on the amount and type of processing we're doing. We need to provide area for all of that. Once we've got all of our recyclables separated, we need to have a storage area for them all. We need storage area for the residuals that come off of our process at the end and we can't do anything with. We may need areas for equipment stored off to the side. And as I mentioned, we may need space for an office or some other type of facilities as well. And then we've got to have a loading area for our residuals to leave our facility and head down the road and go away and be sent for recycling or sent for disposal. Other requirements that come into the design of our MRF, we've got to bring the utilities to this facility, as I mentioned. We've got to have adequate space at the entry and exit of our facility to handle our waste trucks. This is called vehicle queuing. They need space to back up during heavy traffic times so that they're not backing out and causing problems on the roads with traffic. Because we are dealing with waste, we're going to need to provide provisions for washing of equipment at certain times. The floor, it will tend to get slippery and tend to start to smell as well. And that material is going to need to wash in either septic or sewer system as well. So it's another type of utility that typically need to get developed to our site. And as I mentioned, the building is typically a warehouse type of a design. We minimize the placement of internal columns. We try and keep a clear span building so that the support columns for that building are only around the perimeter as much as possible. And we need high ceilings. We've got large equipment running around managing materials inside our facility. And when we've got those conveyors in our facility, we're going up high heights in order to move materials around to take advantage of gravity in keeping things running efficiently. So here's a good example, just a simple example of a manual materials recovery facility. So we've got an area where the trucks come in, deposit their materials. In this instance, we've got sorting tables. And then located adjacent to our sorting tables, we've got separate storage areas for the different types of materials that you're going to be targeting. Tin, aluminum cans, different metals, paper materials, and plastic bottles. Typically, they're stored unprocessed at this point in time. They've been separated out to their different products, but nothing's been done with them. Then, once you get an area filled up, then it would move to a baler where the materials then are baled, and then you need to store the bales so that then they can leave the facility. Again, as you can see here, there's a separate area for residual storage. A simplified diagram of an automated materials recovery facility. And as you can see here with the colors, the first sort that happens in this diagram is we pull out the papers. So this is done with some of those screens as you saw in the video, plus maybe you have people working in conjunction who are just targeting paper off of this material. So that material is pulled out first. Maybe it's the smallest part of the waste stream, so we pull that out first. Second step in the process is metals. And so there's a magnetic separator perhaps to pull out the ferrous metals, and then maybe there's the eddy current to pull out the aluminum, and that can automatically be pulled out. Maybe there's no manual labor needed there. Next step would be an air classifier that's used to separate out light products like the plastics and all of that. And then the last portion of all of this might be, your residuals and all that. That's what comes off the end of the line. So that since residuals may be, 75% of the waste stream, we want to leave it on the belt and let it drop off at the end so we're not touching it, we're not managing it. Again, you see separate areas for the different material storage. Material gets baled and it gets loaded out of the facility. So let's talk about some of the equipment that goes into the design of our MRF, the layout of our MRF. Well, first thing starts with the scale. Typically, this is the first thing that people see when they come on site. Typically, we have to weigh the amount of material that's coming into our facility. We then use that scale to weigh out the materials that are leaving our facility. And then we know how much is coming in and what different materials and how much of those different materials are going out. We've got some sort of sorting that happens. As I mentioned, we may have a sorting table. We may have the conveyors, systems, and all that kind of stuff. Payloader is our mobile equipment that's moving materials around to load into the front end of the sorting equipment, and then to move the segregated recyclables out of storage, out of their separation area into storage, and then out of storage to a baler, and then from the baler to the load out leaving our facility. And then some of the different types of equipment that are used: conveyors. We use hoppers to help keep waste contained and into our system. As I mentioned, trommels to separate materials by size, and magnets, and all the different types of equipment that we need to consider for our facility. So here's some pictures of scales. We typically want to have scales be a straight drive-through type of situation. But our site may limit our ability to be able to do that. And as shown in this lower picture, the lower right picture here, we had a scale. I had to develop a scale because the property was surrounded on 3 sides by water. The vehicles actually had to back up to a scale. So we've got to understand our site. We may have limitations that certain things, are not going to be the most efficient all the time. Here's some pictures of tipping areas. As you can see, waste is just dumped onto the floor, where then it can get managed and moved around with other equipment from there. No separation typically at this point in time. Everything is commingled. We've got to provide some sort of storage at the end of it. Typically, this is done using some sort of a bunker type of system, where we can have physical separation between the different types of materials that are going to leave our facility at the end. And in some cases, again, we may be storing baled materials separately from different types of baled materials. And whether it be inside or it be outside, we need to understand the needs of that storage at the end. Going through our system, there's different types of sorting. There's manual sorting, there's the automatic sorting. As you can see, some of the sorting can get pretty high up in the air because we want to try and take advantage of gravity in the movement of materials as much as possible. Coming to the end of our process, we've got our material typically is going to get baled. There are 2 different types of balers. In the upper right corner, this is what's termed as a horizontal baler, is where the bale comes out of the equipment in the horizontal distance. And in the lower left corner, this is what's called a vertical baler. Horizontal balers tend to be used in much more of an automated type of a system, whereas vertical balers are typically loaded by hand. They're unloaded by hand and baled by hand as well. So much smaller size facilities will tend to lean towards a vertical baler, where automated large facilities will lean more towards a horizontal baler. And some examples of just baled materials sitting there as well. And then we've got to get the facility out of the materials out of our facility. So we have to accommodate the different types of vehicles. Recyclables may leave via a loading dock onto a flatbed trailer or into an enclosed trailer. And residuals going to a landfill perhaps are top loaded. And so we've got to accommodate the different types of loading that may occur at our facility. That runs you through the process of a MRF and how the materials run through and the general thought process we go through in the development of a MRF. And I thank you for your time this afternoon for you.
Thank you, Mr. Kalish. That was really insightful. Participants, you can ask your questions through chat. Mr. Kalish, I just wanted to understand from you, what's the difference in efficiency when it's a dirty MRF and a clean MRF?
Okay, so the efficiency in a clean MRF, you know what materials are being segregated ahead of time, so you know what's coming in. There's much less residual at this point in time, so you can run the materials through your MRF, probably generally speaking in one line, so you can get the materials out in just one pass through. Whereas with a dirty MRF, perhaps once it goes off the end of the line, that material cycles back around and goes into the front of your separation line again, and it goes through a second, perhaps even a third pass at that point in time. So material sits in your facility longer in a dirty MRF because it's harder to get it all at the very first pass through, and so it gets touched a second, perhaps even a third time, and so that's where your efficiency goes down.
Thank you so much. So just so that I'm clear, so there would be a time inefficiency being created, and at the end, the amount of products that you get, right? There would be 2 inefficiencies created. And if possible, could you give some numbers, like rough numbers as to how the time would change in a clean MRF with respect to a dirty MRF?
Okay, so let's just address the time issue. And time would be the amount of time it takes for a particle of waste, the start of your separation process, to come off and be finished at the end of your process. So in a clean MRF, it would pass through one time, one material. Perhaps it's 5 minutes for it to run through, to get the plastic to come off your process. Perhaps it's 10 minutes, something to that effect. But if it goes through, if it's in a dirty MRF and you don't get it all, it has to cycle back around. That 10 minutes may turn into 30 minutes or 40 minutes, depending on what processes are occurring after that occur after that, where that would normally be separated out of your waste stream. It's got to finish going through that process, then cycle back around and go through that process again. So it's not a double, it might be a triple or even a quadruple the amount of time for that particle of waste to go through that process.
Okay.
So the time affects the storage of materials perhaps you need on that tipping floor at the very beginning of your facility. So if it takes longer to process materials through it, you've got to have time built up in storage in the front end of your facility. Now, the materials that come off of it, if your goal is to get approximately, if you're looking to get about the same amount of diversion of saleable materials, and as I mentioned, saleable materials is somewhere in the total recyclables is somewhere in the 40 to 50% of the waste stream as a whole. Okay, if you can separate out some of the papers and things in a diverted up front so that they're kept clean, then you might get a higher diversion percentage overall with a clean MRF, because your papers will tend to be less contaminated as you would with a dirty MRF. But you're still going to get approximately 25% of the waste stream is recoverable. And if you're doing composting with a dirty MRF, then you will recover that contaminated paper, because that is material that is compostable. So if that's part of your dirty MRF process, being able to do composting, then the paper that's contaminated in the second scenario and not diverted or not recycled then can be. So there's a lot of different scenarios, but it can be very equivalent in the output of recyclable materials. So there may not be a difference really between a clean MRF and a dirty MRF in the amount of materials that come off at the end of the process.
Okay. So we have a question. What is the extent of land requirement in terms of size for an MRF?
Well, that certainly is a question that I get all the time. And unfortunately, it's not a straightforward answer. If your MRF, your MRF, is only going to handle 1 ton per day of materials, it's going to be a much smaller sized building, much smaller sized facility. Subsequently, the property is going to need to be much smaller in size. There's going to be less traffic that visits this facility. There's going to be less employees. There's going to be less of everything. But if your facility handles 100 tons per day of materials, there's a much different size requirement. We may have a building that is 100 times bigger than that as a result, maybe even more than 100 times bigger, depending on the amount of processing that ultimately is going to occur. So unfortunately, that's not a simple, straightforward answer.
Okay. Okay, I think this question comes in terms of mega cities in India. Basically, trying to get an idea as to how far or how near the MRF facility can be situated in terms of urban cities. I think that was the basis.
Okay.
But okay, so that makes sense. So I think we have a comment here from a participant. He's saying, I wish presentation might have been linked with Basel Convention and Stockholm Convention. Sure, sir. I think that would be a good idea. Do you want to comment on that? I'm not too sure. Mr. Kalish?
I can't comment on
Okay.
when this presentation should have been linked with something else. So.
Okay. So I think this is to the participants again. You can ask your questions if you have any queries through chat. You have that option on the right-hand side of your screen. Mr. Kalish, we have another question. What is the kind of relation you need to have with the local government for or engagement over here? So Mr. Matthew wants to know what kind of engagement that you need to have with the government before, in order for a successful running of the MRF. Should the municipality, should there be a contract with the municipality into whether they'll be providing certain type of waste to the facility? Do such contracts exist in US?
Okay, certainly, yes. Well, in the U.S., government agencies, municipalities, cities, or counties, as they may be here in the U.S., they have two options, actually. Private companies, the waste managements, the Republics, and those type of folks, they certainly design and build these type of facilities. But municipalities also build them and design them themselves. So in the development of a facility, coordination with the municipality is certainly a very key component in the consideration of that facility. And that would be right from the very beginning of that process. When you're looking at the feasibility of a type of facility, is it going to be welcomed in that community? If your facility is not going to be welcomed in a community, it's going to be hard to permit that facility. It's going to be hard to buy a property, develop a property, all of that. So getting not only the municipality, which may be collecting the waste and delivering the waste to you and taking advantage of the diversion of waste that your facility would be providing, but you also need to reach out to that adjacent community that you're planning to locate a facility, because that community's impression of your facility can hinder the ability to permit it, buy it, get it up and running, and it can hinder your ability to operate that facility over the long term. If there's problems with blowing waste and things, they can get your facility shut down as a nuisance to the community. So reaching out and being involved with not only the municipality, the government, but also the adjacent communities is very important, and important at the very beginning of that process.
Just a follow-up to this. So if the contract, like suppose the municipality tells them, I'll provide you with this kind of waste stream, and if it's unable to comply with it, what happens then? Is there anything of that sort?
Well, you'll typically sign some sort of a contract to have waste delivered to your facility, and if they don't meet the terms of your contract, then that certainly can have problems for you, both economically, but also if you're expecting certain types of waste and certain amounts of waste to come to your facility, you're then designing and building your facility to accommodate those types and those materials of waste. So if all of a sudden that stream changes if they stop bringing certain materials. For example, if you build a dirty MRF and the community, the municipality is delivering materials to you completely, all together, everything commingled, then the amount of recyclables, the materials that you're looking to pull out and take an economic advantage of, are a certain level. But if that community then separately implements after the fact, after they sign a contract, maybe it's a year, maybe it's 2, 3, 4, 5 years down the road, if they then separately implement source separation, where they have households, communities separating out the recyclables in the beginning of that process, because then they're collecting that material separately, and then they're taking that material and sending it to the secondary markets or to somebody else for processing, then that's taking that material out of your economic waste stream. And so there's a big impact to you economically if that type of thing happens. Hopefully, whatever contract that you've got, is strong enough to be able to say, hey, if you separate out those recyclables on the front end, then you bring those clean recyclables to me. And then you got to make sure operationally that you can keep those clean separated materials separate from the dirty commingled materials. And maybe you run the clean stuff through your process first at the beginning of the day and get it separated, and then you manage the waste and pull out whatever's left in the process at that point in time. So, it can have a large effect if that type of thing changes on operations, on economics.
Okay, thank you. I think that would be all for today. Thank you, Mr. Kailash, and thank you to all the participants for joining in. Thank you, Mr. Kailash, for your valuable time. Thank you so much.
Well, thank you for giving me the time to speak with you today.
Thank you. Bye.
Goodbye.